Module 4, Lesson 12. Here we have a problem. A soccer team played 24 games and lost 6. Matt was goalie in half of the winning games and 1/4 of the losing games. The first question asked is, what fraction of the games did the team win? Let's write our focused answer first. So we'll rephrase this question along with a blank. The team won blank, which will be a fraction, of its games. Next, we'll go ahead and draw a fraction bar. And let's decide how we're going to break apart this bar. So it says here, a soccer team played 24 games and lost 6. It says Matt was goalie in half the winning games and 1/4 of the losing games. It's just the first information that we'll need for this problem here. So they played 24 games, lost 6. Do we know part of the whole or the whole? Looks like we know the whole. So they played 24 total games. And out of those games, they won some and they lost some. That soccer team ended up losing 6. So this is the amount they lost, and that amount was 6. So 6 was the amount lost, so the other part was the amount that the team won. And so how do we figure out the amount of games that they won? It would be 24 minus 6, which is 18. That's not what we want, though. What we want is we want the fraction of the games did the team win. So we'll take the amount of games that they won, which is 18, and put it into a fraction of the whole. So that's 18/24. Let's reduce and simplify that. Both of those are divisible by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. So we have a fraction now. The team won what? 3/4 of its games. If we had accidentally put in 18 here and reread our sentence, maybe we would have figured out our error, because it would have said the team won 18 of its games, where it's not a fraction. For the next part of the problem, it's asking, in how many games did Matt play goalie? This is the same question. We're just going to use some different information to be able to help us. We know that there were 24 games total, and from the problem we knew that they had already lost 6. Now, the other part of information that we know from what it is that we had worked out before is that they won 18 games. So we can use our rest of our information from the problem here. It says he was goalie in half the winning games. So, from these winning games, which was 18, so the total's 18. Those are the winning games. 18 games won. He was goalie for half of them. What's half of 18? Right, 9. So this is what we were solving for. And so that's when it is that Matt was goalie for the winning games. For the games where they lost, he was goalie for 1/4 of those games. So, for the lost games, the total was 6. We'll divide 6 into 4 parts. He was goalie for 1/4 of the losing games. So, let's see, 1/4, we're looking at this right here. That's 6 divided by 4, which is equal to 1.5. Perhaps he only played half of a game then. Maybe he had to go home early, or maybe he got hurt, don't know. Or maybe he decided to play a different position for the rest of the game. So, 1.5 for the losing games, and 9 for the winning games. What we'll do with those two numbers? Right, we'll add them. So we have 1.5 plus 9 equals 10.5. So, let's write that out. Matt played goalie for 10.5 games. Is our answer reasonable? Yeah, because 10.5 is still less than 24. And then we had our work to support our answer. I probably should write in a 1.5 here as well. This was the amount of games that they had lost where he was playing goalie. And this one here is the amount of games that he had lost while he had played goalie when the team had won. Okay, here we have another problem. Take a moment to read that problem to yourself. And let's write a focus answer out. Follow along on a piece of scratch paper and bring that scratch paper in, please. What'd you write for your focused answer? Did you write something similar? Think about who and what this problem is talking about. Who is this problem talking about? Right, it's Mrs. Elliot, and it's her garden. How many total flowers are there in her garden? It's 120. Let's start drawing our bar model. Thinking about this problem. All in her garden, there are 120 total flowers. How many different types of flowers are there? Right, 3. We have red flowers. We have yellow flowers. And we also have green flowers. As we look through the problem again, it says, in Mrs. Elliot's garden, 1/4 of the flowers are red. So, that is about 1/4 of the bar. Those are red. How do we figure out that amount that are red? Remember, red was 1/4, right? Or 1/4. And it's 1/4 of 120 of the total. Now 1/3 of the flowers were yellow. So we'll go ahead and label that there. Remember, that was 1/3 of the 120. And this was 1/4 of the 120. Now, the remaining flowers, we don't know that fractional part of that whole number, but we do know that that was green. I'm just going to be a little bit more precise here. And I'll show my work down here below. 1/3 of 120. 1/4 of 120 is equal to 1 times 120 over 4. If I cancel the 4 to become a 1, the 120 actually becomes a 30. 30 over 1 is 30. Pause the video, figure out 1/3 of 120 on your own. Did you do something similar? Did you use a cancel approach? Ideally, you did get 40. So, putting these numbers in around our bar model, we know 30 are red, we know that 40 are yellow, and we know the rest are green. It says how many flowers are green. So, we can just work with our numbers for our flowers. It's the total amount of flowers subtracting the total red and yellow flowers there are. 30 plus 40 is 70. We have 120 minus 70, which would be 50. There are 50 green flowers. Let's look at this problem, and that was the flower problem still. What if it asked a follow-up question, like, what fraction of the flowers were green? These numbers still help us, and the numbers that help us, all we need are actually the total number of flowers, and we also need to know the number of green flowers. So it would be the number of green flowers over the total. 50 of the 120 flowers, or 50 120ths, is the fraction of flowers that are green. The only thing that we would need to do with that, though, is to reduce and simplify it, and then we could say 5/12 of the flowers were green. And then so that's a fraction. The fraction of flowers that were green was or is 5/12. Now, just to show you, look what we have here. This was 5/12. And from our problem before, it was 1/4 of the flowers being red and 1/3 of the flowers being yellow. When we had those fractional parts there and we add up those fractional parts, 1/4 does equal 3/12. 1/3 equals 4/12. And if we added all the flowers and the fractional parts of the flowers in the garden together, we would have gotten the whole garden, or 1. Just some different ways to look at and think about these problems.